So let us try to understand this program completely through the more concrete example. For your convenience, I have copy and paste the same program on the left side of the screen. So while we walk through the example, you can have a program to look into, and I can point out every single line corresponding to the example. Starting with the program, you see that we have input past the array A as the parameter, and this is our array. First of all, we try to understand how many elements that we have so that we can have our for loop to designate the starting point as well as the end point. Therefore, since we have 10 elements in the array, n equals to 10 over here, then we initiate a variable maximum sum to store the maximum sum that we have currently found. And therefore, we have a maximum sum initiated as 0. So since we have not started anything, we would initiate it equals to 0. And then we will look into the loop. Starting for the I loop, it will start with the location of 0, I less than n, I plus plus. So basically the I loop will move every single item from beginning to the end of the array A. And then the nested loop under the I loop is going to be the J loop. The J will start it where I started until the end of the array, and then J will move to the next one. So you can see that in the very beginning of the example, J will equal to I equal to 0. So initially we will have our I and J starting point at the index of 0. Then we initiate the sum, this sum equal to 0. So we have initiated this sum equal to 0 over here. And finally, we will walk into the K loop. The K loop will go through I location until the J location, and whatever elements stays in that range, we will try to sum all the values up. Every time we run the K loop, we will initiate this sum equal to 0 so that we can have a clean start, and then the K loop will take care of all the sum between I and J for us. So basically you can see that since I was starting from the beginning and goes to the end, and J will start where I started, goes to the end, we basically, this two loop creates all combinations of I and J, and so that we will be able to test out every single combination. With the help of the K loop, we will be able to sum up every single items in that range. During the process, whenever we see this sum is greater than the maximum sum, we would store that information because potentially that can be our answer, and therefore we will replace maximum sum with this sum. And we also want to remember where does it start and where does it end. The starting point is corresponding to the I, and the end point is corresponding to the J. So that is what's going on with the initial steps of the example. Of course, once we go through that, we will find this sum equal to -2, starting with index of 0, end with index of 0, then this sum is equal to -2. Since -2 is not greater than the maximum sum, while our maximum sum currently is 0, we will not go into the if statement. Next. After that, the whole thing will go back. J will increment by 1, so J will move from 0 to 1. Now, we still have maximum sum equal to 0, I equal to 0, J equals to 1. So once that is done, we will need to initiate this sum equal to 0 again, and then go into the K loop. So inside of the K loop, it will walk through every single element in the range of I and J. So it will go through the index A of index 0, A of index 1, give you -2 and give you 4. So we will sum up all the values together, finding out the value is 2. This time, 2 is greater than the current maximum sum, so that we will want to go into the if statement, replace the maximum sum equal to this sum, which is 2, and then remember where does it start and where does it end to get this current maximum sum. Next, we will move our J again, go back over here, J will increment by 1, so J will look into the next location, and in this case, we will have the current maximum sum equals to 2, I equal to 0, j equals to 2. Initiate again this sum equal to 0. Use the K loop to help us sums up all three elements in between, get a value of -1. -1 is not greater than maximum sum that we have, so it will not go into the if statement. Again, go back, j will move to the next location, initiate this sum equal to 0, sums up all the values in between 0 and 3 index, we get a value of equals to 1. 1 is not greater than maximum sum, which is 2, we will move on. In the next change, you can see that j will move to the next location, initiate this sum equal to 0, and then use the K loop to walk through every single item. There are 5 items, and then we get the value of 8. At this time, 8 is greater than maximum sum, so we want to store that information, and so that we will replace maximum sum equals to 8. Starting location is 0, end location is j. So now we will go into the next movement. J will increment by 1, go through all the elements in the K loop equal to 4, not greater than maximum sum. So we will keep searching. J will move to the next one, finding out the sum between I and j are -4, not giving you any good. So we will keep moving j to the next location, get 1, not greater than maximum, go to the next location, 5, still not greater than maximum 1, and then goes to the last location for the j, finding out equals to 4, still not greater than maximum. So that j loop has been finished. We will be able to go back to I loop, and then I will increment by 1, and j will starting where I started. So you can see that in this case, we will have a new start. At the same time, we still remember the current maximum sum find is 8, and then when I equal to 1, j equals to 1, we're starting with this location, getting the value this sum equal to 0 with the K loop, starting with index 1, end with index 1, finding out the value this sum is 4. So no good. Move to the next location, j, and then it will sums up 4 and -3, get you a value of 1, still no good. Move to the next one, give you a value of 3, still less than the maximum sum. And then you can see here is when j move to the next location, you will be able to find the sum between 4, -3, 2, and 7, give you the value of 10. And that time it is greater, so we will be able to store that information, and j will keep moving. At this time, maximum sum is 10. When I equal to 1, j equals to 5, then the sum is 4. So basically, j will keep moving until the end of it. I will move to 2, and then j will start with 2, go through each items, and then we will repeat the whole process again and again until I and j reaches 9, and that will be the end of the program. And of course, throughout the whole process, whenever the value is greater than maximum sum, then we will replace that. And when we walk through all the process, we basically definitely can find the maximum value of all. So this is the brute force way, test out all combinations. And like I mentioned earlier, because this program has 3 loops that are nested to each other. Each one of that is go through about n elements. So it's n multiply n, and then give us a n cube operation. This is going to take some time for a data set that are large. So the idea is that this is how we can do as the worst case scenario. And we want to say we want to improve it. How can we improve? How can we change in from this n cube operation, say, to n squared, which means that if we can remove one of the loop, then we basically will be able to improve from n cube operation to an n squared operation. So that's, of course, there's a way of doing that. An improvement algorithm makes use of the fact that, okay, if we already calculate the sum for the subsequence I to j minus 1, then we only need one more addition. Instead of go through the whole process of the k, because k, every time when k loop is happening, we need to calculate the sum from I to j pointed and sum all the values. While we j move to the next location, there's actually only one additional item. So if we don't forget the value and then just add that value back in, we don't need to have a k loop to calculate all the values between I and j. So if we do that, the idea is this, and we can put the two algorithms side by side to do the comparison. In this algorithm, n square algorithm, you can see that the beginning point are the same. The for loop is still the same. The difference is this. After the for loop and before the j loop, we initiate this sum equal to 0. So every time when I starting with one location, we reset this sum. But inside of the j loop, this is the major thing. Every time this sum will only increment the next item. And don't forget about the item while j is moving. In this case, if this sum is greater than the maximum sum, we try to remember the information. And this, by doing this, as well as initiated this sum in this location, we can eliminate the whole k loop. And that gives us a much better performance. So let's take a look at what's happening over here. I'm going to move into the n square on the program, and then you can try to see what's happening over here. Initially, when I and j located an index of 0, we initiated n equal to 10, maximum equal to 0. We have a new star. When I equals to 0, this sum set as 0. J will start it with the location of I, and this sum will be -2. The major changes will show up in the next slide. When j moves to the next location, you see that when j moves to the next location, we are not changing anything over here. We simply, this sum equals to -2 because we get this sum in -2 in our previous step. And then we simply move to the next location. So +4 is going to give you the next value. We get a value equals to 2 over here. Since 2 is greater than maximum sum, we store the information. And then when we move j to the next location, we already know that -2 plus 4, which are the two values before that, is 2. So we don't need to recalculate that at all. Simply put -3, add to the previous result, we get a -1, and we already know that's the sum of it. So we don't need a k loop to walk through all the items, because we remember what was happening before that. And then you can see that after that, because the previous result is -1 already, all I need to do is sums up whatever j location is. So we +2, get a value of 1, have 1 plus 7, go into the next item, get a value of 8. We can do remembering the maximum values that we have found so far. And the same thing, plus -4. So you can see plus -4 equal to 4, and then 4 plus -8 equals to -4. And we can be able to walk through all the items one by one until the end of it. Every time we do that, we basically just add that current item j pointed at as the sum of the sequence. When j walk through everything, I will move to the next location. That is when we need to reset the value. And this time we get a sum equal to 4. Going to the next one, we will get plus -3, plus 2, plus 7. And that's when we get the maximum value of the example. And of course, we will be able to keep walking through all the locations, still calculating all combinations, just with a better program to walk through all combinations.